We are continuing with the equations of a straight line. Here he is saying that without using distance formula, show that the points A, B, C and D are the vertices of the parallelogram. Now we don't have to make use of the distance formula. Otherwise we could have found it with the distance formula. Distance, suppose this is A and the coordinates of A are 1 and minus 2. This is my B and the coordinates of B are 3 and 6. This is C, here it is 5 and 10. And this is D, coordinates are 3 and 2. If I was allowed to prove this quadrilateral as a parallelogram, I would have used the distance formula and found AD equal to BC and DC equal to AB, right? But I'm not supposed to use the distance formula. I'm supposed to prove it without distance formula. So how will I do that? See, another property of a parallelogram is that if you are able to prove that opposite sides are parallel, both the pairs you have to prove are parallel, then the figure is a parallelogram. This is the property of a parallelogram. So with the slope, if I prove that AD, if the slope of AD is equal to BC, that means AD is parallel to BC. Similarly, if I prove that DC, slope of DC is equal to slope of AB, I can say that DC is parallel to AB. So I have proved that ABCD is a parallelogram, right? So I can prove this by finding the slopes of all the sides. So we can say if slope of DA or AD is equal to slope of, then you have to write BC. If you are writing AD here, if you would have written DA here, then this side you had to write CB. But if you are writing AD, then take BC, slope of BC. And if slope of DC is equal to slope of AB, then ABCD is a parallelogram, right? So let's proceed to find these first. We will find the slope of A, whose coordinates are 1 and minus 2, and D, the coordinates are 3 and 2, right? This becomes my x1, y1. This becomes my x2, y2. So slope of AD is equal to y2 minus y1 upon x2 minus x1, which is 2 minus of minus 2 upon x2 is 3 minus 1. So this becomes 2 plus 2 is 4 by 2, 2 2s are, so this becomes 2. So you have calculated the slope of AD. Now this should be equal to the slope of BC. So let's calculate the slope of BC now. Slope of B, let's write the coordinates of B, that is 3 and 6, and the coordinates of C are 5 and 10. Now this becomes my x1, this is my y1, this is my x2, this is my y2. So this is equal to y2 minus y1 upon x2 minus x1. So y2 is 10 minus 6 upon 5 minus 3, which is 4 upon 2. So you have proved that slope of AD is equal to slope of BC, right? Now let's proceed to find the slope of DC. Now slope of DC, first we'll write the coordinates of D as 3 and 2 and the coordinates of C as 5 and 10. Now this becomes my x1, this is y1, x2 and y2. So y2 minus y1 upon x2 minus x1 is 10 minus 2 upon 5 minus 3. This is 8 by 2. This is 4, right? So I have calculated the slope of DC as 4. Now slope of AB should also be 4. then this quadrilateral will be a parallelogram. Now slope of A is 1 and minus 2, and B it is 3 and 6. So this is my x1, this is my y1, this is x2, this is y2. So this is equal to y2 minus y1 upon x2 minus x1. So y2 is 6 minus of minus 2, x2 is 3 minus 1. So this is 6 plus 2 is 8 upon 2, which is 4. So you got the slope of BC equal to the slope of AC. Now what do you conclude from here? You conclude that since the slope of AD is equal to slope of BC, therefore AD is parallel to BC, and from here you are concluding that slope of DC is equal to slope of AC. So DC is parallel to AB. Therefore, if opposite pair of sides are parallel, the quadrilateral is a parallelogram. Therefore, ABCD is a parallelogram.